Okay, this is question number 25, which is a doubt of one of the students, and this is from the assignment on equation of waves. And we have to find out the wave equation, and we have to check in which direction is the wave moving. Now, in which direction is the wave moving? That's very easy to figure out, because it is given that at t equal to 0, the particle at x equal to 0 here, it's actually moving upward. So you can shift the wave. Let's say we shift the wave towards right a little bit. So if we shift the wave towards right like this, then what do we find is that the old position of x equal to 0 particle is 1 and new position of x equal to 0 particle is 2. So we can say that this particle at x equal to 0 has gone up, and actually it is given in the question that it is going up only. Okay, so our assumption that we are shifting the wave towards right in delta t time is correct, which means that the wave is traveling in plus x. So this is fine. Okay, now let us check how do we find out the equation of the wave. So wave equation is of the form of y is equal to a sine of omega t minus kx plus phi. So there are four things to find. First a, then k, omega and phi. If we can find out these four things, then it's done. So let's start with a. Well, a is already given, which is the maximum distance that any particle can go. So which is like the height of the wave kind of thing. So it is 10 millimeter. 10 millimeter. As far as lambda is considered, well, that is also indirectly given, because lambda by 4 is given. So this distance will be lambda by 4, as you know, because of the symmetry. So this is also lambda by 4. And sorry, this is not lambda by 4. Between mean position and extreme position particle. Okay, because you may be knowing that if you draw a wave like this, then this entire thing is lambda, then this is lambda by 4, sorry, lambda by 2, and half of that will be lambda by 4. So particle at mean position, particle at extreme position, the horizontal distance between them is lambda by 4. So mean position, this is at mean position A, the other is at mean position B. Sorry, A is at mean position, B is at extreme position. The distance horizontal between them is lambda by 4, which is 3 given. So from here we can understand that lambda by 4 equal to 3, or lambda is equal to 12 centimeter. What about K? K is equal to 2 pi by lambda, so by 12, which is pi by 6 meter inverse. So this is K. Okay, now particle's speed is given for the particle at x equal to 0. Now let's talk about this particle, because there is some information given regarding this particle. Let's call this particle as particle D. Okay, now let's try to understand what is the phase of oscillation of this particle. So if we shift this wave towards right a little bit, then we can see that this particle D is going up. So the particle D is at its mean position and it's going up. So if you represent its motion with that circular phasor diagram, mean position and going up. So mean position also, so mean position means the corresponding circular motion particle, either it can be at this point P or at this point Q. However, if you draw the circular motion particle to be at P, the problem is that this circular motion particle is going down, and so our SHM particle, which is like the projection kind of thing of this circular motion particle, that is also going down, which is not correct, because this particle D is going up. So we should represent this particle D with the circular motion particle Q. All right, now we know that as we go in the direction of wave, the phase decreases. So when we go a little bit towards right, we come to point M. Then we go a little bit towards right, we come to point N. We go a little bit towards right, we come to point Z. And then we go a little bit towards right, we go to point O. And along the direction of wave, the phase decreases. So we are going to decreasing phase. So if we represent all these particles which are undergoing SHM with their corresponding circular motion particle, so if this Q point is here, then the downstream or down the or along the direction of propagation of wave as the particles are coming, we will represent those particles clockwise of this particle q, because they are having smaller phase, and a smaller phase means clockwise. So m will be represented by here, then n will be here, then z will be here, and o is also somewhere here only. So basically, to go from this particle d to particle o, how much is the phase difference, by the way? So we know that phase difference is related by delta x. So you may be remembering this formula, that there is a particle at x1, there is a particle at x2, and it will have the phase of like omega t minus k x1 plus phi, and this will have like omega t minus k x2 plus phi kind of thing. And so the phase of x1 minus phase of x2 is equal to 2 pi by lambda or k times of x2 minus x1. Now this x1 is particle at d, x2 is particle at o. So 2 pi by lambda, x2 means particle at o. Particle at o has got x as 0 and particle at d has x of minus 2. So we get phase of oscillation of d minus the phase of oscillation of o as 2 pi by lambda multiplied by 2. Now lambda is given to be 12. So we get this 12 here. So it's like pi by 3. So phase difference is pi by 3, which means we will be representing this O point pi by 3 angle clockwise of Q. So here we have this pi by particle O, and this angle is pi by 3. Now what is the displacement from mean position? Displacement from mean position is a root 3 by 2 with a negative sign. So what is the velocity of O? O is undergoing SHM. In SHM, the velocity is represented by omega root over a square minus x square, where x is the displacement from mean position. So velocity of O is omega root over a square minus its displacement is minus a root 3 by 2 whole square. So as far as its speed is considered, this is omega a by 2. Now this omega a by 2 value is given because it's given that this particle at x equal to 0 is moving with a speed of 2 centimeter per second. So 2 is its velocity. So 2 centimeter per second is equal to omega a by 2. So 2 centimeter per second is equal to omega into, what is a? A is 10 millimeter, alright. So 10 by 10 centimeter, and this is a, that you need to divide it by 2. So omega is 4. Now omega is 2 pi f, linear frequency. So f is equal to 2 by pi. So that is what is the B option. Frequency is 2 by pi. So this is also fine. Wavelength we have already calculated. So what do we have now? We have y is equal to 10 millimeter sine of omega. Omega we calculated as 4. So 4 t minus k. K is 2 pi by lambda, which is pi by 6. Pi by 6 x plus 5. Now what about the phase? Initial phase of SHM of particle at x equal to 0. So x equal to 0 particle is here. So how much is its phase? So phase will be this angle. So phase will be like, so this is pi by 3. So phase is equal to 2 pi minus pi by 3, which is like 5 pi by 3. Since the phase is 5 pi by 3, so this option is wrong. So the correct answer is A, B and D.